Hello, everyone. How are you guys doing? Hi, Queenie. Peace. Yusuf. Shian. Nishia. Emily. Ryan. Yasmin. Wendy. Hi to all of you. I feel like I've seen you after a long time. Oh, no. I didn't see you for a long time. But we met Monday. Yeah, it's been almost 10 days. Yeah. No wonder. I feel like I didn't see you for a long time. Restful break. Well, it wasn't too restful because I was grading many papers and we I had many assignments for myself. So yeah, but it was good, not bad. How about you guys? Yeah, I'm done grading all the papers. So I'm happy about that. Yesterday, the whole day I graded. I think it took me only few hours to grade few papers, but I'm actually a slow grader. I hate that when many other instructors, they can grade one complete exam for everyone in one class in half an hour. It takes me almost 10 hours to grade only one class. So that's why I hate giving exam and grading them. But we must give exam, grade exam. So yeah, you have your exam coming up on Monday, which is only a few days from today. So my plan is to do a review. Even though we did not finish chapter 8, but all we have to do is from chapter 8, do 2 types of question and you'll be fine. So before we start, any question from anyone? Any comments, any concern, any complaint, anything at all you want me to discuss? About cheat sheet, you're allowed to use one-sided cheat sheet. For me, the paper size doesn't matter. As long as nobody finds out, you're allowed to use any size paper. And you can put any formulas, any information you want, but please don't print out my review sheet and treat that as your cheat sheet. I don't want you to do that. If I see you printed out my review sheet and solved every question in there and brought that in class for exam, you're not allowed to use that. What would you say would be the best way to practice for this exam? Do every question from the review sheet. I always make my exam based on the review sheet, but in the review sheet, you see one scenario. In the exam, you're not going to see the same scenario, but the situation will be same. For example, here it says a chromosome defect occurs, blah, blah, blah. So you're talking about chromosome defect in people. Maybe in the exam, it will say different scenario. For example, once in every 1,000 people, they have some type of, or maybe 1 in 10 people, they like coffee, something like that. Okay. Or maybe I'll give you the decimal, like 60% people hate doing their homework, something like that. So the situation will be different, but you have to do the same thing. Find the mean, find the standard deviation for the proportion, and find the mean, standard deviation for the sample mean. Okay, so if you know the process of solving something, it doesn't matter what scenario you see in the exam, you'll be able to do it by following the steps. So you can write down the steps, but make sure you don't use my review sheet and write all the solutions in the review sheet and bring that. Nope. You can use all the formulas I give you. For example, here in the review sheet, if you notice, I give all the necessary information from every section, 7 and 8. 6 doesn't have anything to give in organized manner. So for 7 and 8, I gave you all the necessary information. Yes, you definitely can print that out, but don't print out the whole review sheet and solve the question in there. It's during regular class time. Yep, it's during regular class time, and you'll have the entire class period, even though you're supposed to have only 1 hour, but I don't mind giving you extra 15 minutes. Okay, and there will be one from sample mean, one from the population. Oh man, my pen is stopped working. So there will be 2 questions from chapter 8. There will be 3 questions from chapter 7. 3 questions from chapter 7 because we have 3 topics in chapter 7. So, okay, great. So chapter 7, it has discrete, normal, and binomial. So I'm going to give 1 from each topic. These won't be too bad. This will be like this type of question. Okay. So this is discrete. This is binomial, and these are normal. These 2 are normal distribution example. So obviously I'm not going to give you this scenario that you have salary for this, figure out that and that. You're going to do 1 from here, 1 of these. I'm giving you 1 of these in the exam, but the scenario will be completely different. Okay, but I'll definitely tell you that it follows a normal distribution and the people are randomly selected. So if you have a normal distribution and people are randomly selected, you can use the method, same method what you use to solve this one. So these 2 are the hints. As soon as you see them, you'll know that, oh, this is from chapter 7 and the same method you have to apply. And these will be straightforward. Find the z-value and draw the area. These will be simple question, like 6 points. 1 point for each z-value and 1 point for each area you draw. But this will be a math question. Well, how many questions I'm still making? I'm putting many questions and then reducing them, putting another question, reducing them. So I actually don't know how many questions to put for 1 hour, 15 minutes. So what currently I have is 2 questions from chapter 8, 3 questions from chapter 7. These are not long, okay? These are short questions. All you have to know how to get the answer. These are not big math question. Chapter 6, probably 3, because these are probably, oh no, chapter 6 is 4. For question 5, yes. So 4 question from chapter 6, because probability takes up so many topics and Usually in the final exam, they give lots of questions from chapter 6. Chapter 5, we skipped. And from chapter 1 to 4, there is a one big question, but it has 5 parts. For example, find mean, median, mode, range. Find 5-number summary. Find IQR. Draw box and whisker plot. And draw stem and leaf plot. Okay, so combining all the information, there'll be one question, but it has multiple parts. Question 1 from chapter 1 to 4 with multiple parts. But again, I'm going to give you a shorter data set, like 10 entry in the data set. So like I'm trying to make the exam as small as possible. So my math portion is small. However, I have 2 pages. The other thing, fill in the blank, true, false, those type. And those type of question, you can find them in my lecture video. Like during every lecture, I said, oh, this is a good example for exam. This is another good example for exam. So I actually put together all those things I said, a good example for exam, and then I put them in the exam, and each of them are 1 point. And combining them, I actually have almost 30 points. 30 points in filling the blank and those type of questions. For example, I give you a scenario and I'll ask you, what is the sample here? What is the population here? Or I'll give you a scenario and ask you, is this observational or is this experimental? What do you think about the process? And you definitely should know all types of visual representation of data. For example, pie chart. What is pie chart? What is dot plot? What is histogram? What is bar graph? What is comparative bar graph? Those things. Like in chapter 3, I think, or 4, I don't remember exactly. I think chapter 3, we talked about what are the ways we can represent our data to visualize them. So make sure you know each of them. And for example, I don't remember which chapter, but during few lectures, I said, what did I say? What's the name? Variability. Chapter 5, we didn't do it. We're going to do it at the very end of the semester. Chapter 5. Measure of central tendency. You should know what are these. Also, measure of variability. You should know those. What else? Measure of central tendency, measure of variability, sample, population, observation, experiment, those things. Yes, 1 to 8 chapter, except 5. So let me see from the beginning. So this is what I meant. From chapter 1 to 4, there'll be one question, but it has so many parts. Mean, median, mode, range, ordered. Remember, ordered means you have to arrange them smaller to bigger. So ordered stem and leaf plot, 5-number summary, and then IQR, and then box and whisker plot. Box and whisker plot. Okay, I've seen so many things based on one data set. And then probability has many questions. It's better if you understand how to do each of those. Some of them will be inside multiple choice question or fill in the blank question. Few of them will be real math, inside the real math part. And chapter 7, I told you 3 questions based on 3 topics. Chapter 8, 2 questions based on 2 topics. And I'll put 3 or 4 questions extra credits. Okay. Any question? Comments? Concern? Okay, great. Now let's finish our chapter 8. So chapter 8 has only 2 topics. One is working with the sampling distribution of sample mean, and another is sampling distribution of sample proportion. So sample mean means we have many means from many samples, and then to the average of all those means. That's sample mean. Sample proportion is, on the other hand, we have one sample. In that one sample, we take many subsample. For example, if you have 100 people in your sample, then you take many proportion of same size. Let's say you're taking 5. So 5 out of 100, and you see this is the proportion. And then you take another sample of another group, and then you take like this, you take many subsamples and find their mean, and then find the mean of those means. So since we use only one sample, and from that one sample we took subsamples, so we actually working with sample proportion. So whatever we get from there, it's the sample proportion. So we call it sampling distribution of sample proportion. But they have the same process. They're based on the population. And whatever average we get, either by using sample mean or sample proportion, it doesn't matter. The mean, the final mean we get from those is same as the population mean. So this is what means mu of x bar equals mu. It means the mean of the sampling distribution of sample mean is same as the mean of the population. Here it says the mean of the sample proportion is P. It means the mean of the sample proportion is same as the mean of the population proportion. So when we use proportion, we use P. To represent sample proportion, we use P hat. To represent population proportion, we use simple P. And this P are small p, not the big P. And for standard deviation, we have different formulas. When you're working with mean, the standard deviation for the mean is population mean over square root of n. But when you're working with proportion, then the mean for the sample proportion is this thingy. It's a big formula. I mean, not big, kind of larger than, I mean, it takes more time, more math than the average X bar. But that's all you have to know, okay? In chapter 8. So let's do 2 examples. The first one, the random sample of 64 people is selected from a population. So we have a sample of 64 people that are drawn from the population, and that population has a mean 80 and standard deviation 10. So population mean is 80 and population standard deviation is 10. Now they want us to find out what is the mean of the sampling distribution of the sample mean. So since you're working with sample mean and you can already see it's X bar, that means it's the first portion. The first portion says the mean of the sample mean is same as the population mean. In other words, it's 80. So we don't need any math, it's given to us automatically or given to us directly. We can see it clearly. And then it says also do the same thing for standard deviation. Find the standard deviation of the sample mean. So standard deviation of the sample mean, it's population mean divided by square root of your sample size. Since we took a sample of 64, so our sample size is 64. And they already told us our population mean is 10, so it's 10 over 8. And that's all you have to do. Find the mean. We don't even have to find it, it's given. But do the calculation and find the standard deviation. Same scenario is in the proportion case. It says a certain chromosome defect occurs in only 1 out of 160 Caucasian male. So if you have 160 adults, among them, there's one of them definitely have some type of, a certain type of chromosome defect. Now, we took a random sample of 100 people from those people, and they want us to find the mean and standard deviation of our sample proportion. So we have a sample size of 100. Now, what they want us to find, they want us to find mean and standard deviation, but what does it mean? Well, it means if you took many random sample of the same size, in our case it's 100, and calculate the proportion of individuals with the defect in each sample, the average of all sample proportions would be equal to the true population proportion. In other words, from all the people in our population, if you take, sorry, before what I said was kind of wrong. If you take 100 people as a sample, then you see among these 100 people, how many has chromosome defects? And then keep doing it. In 100, take another 100, a sample of 100 people and see how many people you have. And then you do another 100 people and then see how many of them have. Take the average of all of those. But since these are proportion, so we're not going to use X bar. Instead, we are going to use P hat. So this has P hat 1. This is P hat 2. This is P hat 3. So find all the P hat and then find the average, the total average of the P hat. This will be same as the average of the population. But since we're not going to work with bar, X bar or mu, so this is same as P, which is the average for the population. Okay, so depending on what scenario you're working with, either you use mu for population mean or use P for population mean. If you're working with proportion, it's P, but if you're working with number, then it's mean. Anything else? Oh, and then the standard deviation of the proportion, sample proportion, is this formula. This concept relates on the idea that the sample proportion tend to center around the true population proportion if the people you are working with is drawn randomly and they have unbiasedness in their sample. So find the mean and standard deviation. We don't need to do much math. For mean, let me resolve this. For mean, it's already given to us. So if you have the information in a cheat sheet, you can see clearly what is given to us. So make sure you have this information in a cheat sheet with all the details like I put them here. So it says mean of the sample proportion is same as the mean of the population proportion. So mean of the sample proportion is same as the mean of the population proportion. But this, people don't use it. Instead, they use simple P. So our question is, what is P? Well, P is given in the first sentence. It says 1 in 160 Caucasian males. So this Caucasian male represent the population. And in the population, 1 out of every 160 people have chromosome defect. So the first sentence is telling us the information about population. So 1 out of 160 people get the defect. So this is our P. This is not P hat because this 160 is not based on a sample. It's based on the population. We have a whole Caucasian male population, and in the entire population, 1 out of every 160 adults has that defect. So this is the mean. For standard deviation of the sample proportion, we have a formula. P1 minus P over N, take the square root. Now this N is your sample size. So it says, see a random sample of 100 adults you selected. So that means your sample size has 100 people. And P, we already know 1 out of 160. So it's 1 minus 1 out of 160. Take the square root. And this is actually from the homework. Okay. So the answers for this question, you'll find them in the homework. The next one says, does P hat have approximately normal distribution in this case? So before we said when we have at least 30 people in our sample size, it's kind of represents a normal distribution. And I also said at the same time that, well, this is not always true. Now observe here, we have our N 100 people. So obviously we have a normal distribution, right? You may think we have a normal distribution, but look what happens. In order to have a normal distribution, there are two conditions. One is N times P, they have to be at least 10. Also, N times 1 minus P, they have to be at least 10. If these two conditions, at least one of these conditions doesn't satisfy, then nope, even you have 1,000 people in a sample size, it's still not normal distribution. So these two conditions are the main concern. If one of them fails, then you don't have anything. So we have N 100 and our P is 1 out of 160. So 0, 0 cancel out, you get 10 out of 16. Obviously, this is not more than 10, right? We can always see it's less, it's even less than 1. So nope, they don't have normal distribution, even though we have 100 people in our sample. Still, we don't have a normal distribution. Well, since we figured that out, we don't have a normal distribution, even with the 100 people, our next question is, how many people actually we need here in order to have a normal distribution? Okay, we go back to our condition. Condition says, as long as you have these two, then you have a normal distribution. So you're looking for how many people we need. That means we can divide both by P. So number of people we need must be 10 divided by P. So we have 10 divided by 1 out of 160. Keep, change, flip. That gives us 10 times 160. That means we need at least 1,600 people in order to have a normal distribution. Okay, and you can also use this one. So n has to be 10 over 1 minus p. So 10 over 159 out of 160. Keep, change, flip. It will give you another number, but you can take the smaller one, I think, or bigger one, I forgot. But as long as you use this, mostly we are fine. Well, I think we take bigger one. Because if you do this, it's 1,600 divided by 159, which is smaller than 1,600. So this will give a small number. So this is something small, and this is something bigger. Obviously, we need to apply the bigger one. Any question? Was anybody confused so far? No. So that's all about chapter 8. Chapter 7 has 3 types of question. The first, go ahead, Yusuf.
Yeah, sorry, can you go back to the previous question? Right. So essentially, like the strategy here is that we have to compare these two, like the NP is more than or
Requirements.
equal to. So we have to compare them because they both have to be true. Is that what it is? They both have to be true in order for
Exactly. They both have to be
distribution to
true
be
in
normal.
order to have a normal distribution.
Okay, so what about the second one? If it's a small number, uh, does that make it like not true then? Or
Exactly.
do you just
So
take
B says, you're talking about B or C? Which one?
C?
Okay, so we found that NP bigger than 10 tells us we need at least 1,600 people. And if we apply N1 minus P bigger than 10, we need at least 1,600 divided by 159. So this is small, right?
Yeah.
Around 100 is something. So if you have, first one says you need at least that many people. Second one says you need this many people. So if you compare them, which one makes sense? How many people actually you need in order to have both conditions satisfied?
It's the first one.
The bigger one.
Got it. Okay.
That's why usually if you do this, we are done, because the other one mostly gives us smaller number. But the smaller number doesn't work for the first question NP. Okay, clear?
Yeah, all good.
Okay, so chapter 7, the first one is a table. So to find the missing one, it's 1 minus, you add all of these, whatever you get, that's the probability for the 7 one. So what is the sum of all the probabilities? Do you remember? Sum of all the probabilities must be 1. And probability lies between which two numbers? 0 and 1. Make sure you remember the engineering exam. So probability of 7 is 1 minus sum of all the probabilities. And then at least means at least 5 or more. So probability of 5 plus probability of 6 plus probability of 7. So find the probability, they're in the box. All you have to do is get them, add them. At most mean 5 or less. So probability of 1 to probability of 5. So if you're confused about what is at least, what is at most, think about real life. What does at least mean in real life and what is at most mean in real life? Things will be easier for you. When you have equal sign, it means you're including the two ends. So it's probability of 2 till probability of 6. You're including both of them. On the other hand, when you don't have the equal sign, that means you don't include the end. You only take the middle. Between 2 and 6, we have 3, 4, and 5. That's the difference between them. One includes the end, the other one doesn't include the end. Find the mean. Since this is discrete, so mean of the discrete random variable is sum of x times their individual probabilities. That means you take 1 times that, 0.03. You take 2 times that, 0.05. It takes 3 times that, 3 times 0.09. And you add up to 7 times its probability. Whatever you get, that's the mean of discrete random variable. And for binomial, when you see that if you do the experiment once, there is only 2 choices, that means it's binomial. For example, if you do true-false question, there are only 2 choices, true or false. So you can answer this using binomial. Or if you flip a coin, there are only 2 choices, either head or tail. So it's a binomial. So anytime you see a situation, you ask yourself, if I conduct the experiment once, how many outcome we have for one experiment? If it's 2, you can always use binomial method. So let me use this. So for binomial, the mean and standard deviation is very easy. The mean is n times p. P means the probability of success. Usually it's always 1/2. Usually, not always. Sorry, my bad. If you're flipping a coin, then it's 1/2. Otherwise, probably it will be given. For example, if you conduct an experiment and you have only 2 choices, either success or failure, so it's a binomial. Maybe your success rate is 0.6, that means your failure rate is 0.4. So our probability, P means probability of success. Probability of success, it depends on your experiment, whatever experiment you are conducting. But the mean is easy. It's n times p, and standard deviation is n times p times 1 minus p. take the square root of that. And let's say you don't know your P. What's the probability? Never mind. You'll know your probability. Let's say you don't know probability of getting a certain number. Then to find the probability, this is the formula. For example, here it says we are tossing a coin 4 times, and we want to see what's the probability of getting exactly 3 heads. So we don't know that probability. So you have to find the probability, you can use this formula. Or we want to see if we toss it 4 times, what's the probability that we get at least 1 tail? So at least 1 anything. It doesn't matter anything. It could be tail, head, success, failure, or true, false, those type of. At least once, it means 1 minus probability of none. Okay, so we love at least question because we don't have to do math. It's simply 1 minus the complement. So here is asking for at least 1 tail. It means 1 minus probability of no tail. And when you're flipping it for 4 times, it doesn't matter whether you're flipping it 4 times or 400 times, doesn't matter. No tail happens only once when you have all heads. So this is same as 1 minus probability of all heads. And all head happens only once out of whatever thing you're doing. So here the total number of sample space is 2 to the power how many times you're conducting your experiment. So we have 2 choices and we are doing our experiment 4 times. So it's 2 to the power 4. So 1 minus 2 to the power 4, that gives us 15 over 16. Because 2 to the 4 is 16. And find the mean and standard deviation. So mean is NP. We are doing it for 4 times, and probability of tail is 1/2. So P means the success rate for tail. So it's 1/2 of 4, which is 2. For standard deviation, it's NP 1 minus P under the square root. We already know our NP is 2. So this is 2, and 1 minus P means 1 minus 1/2, which is 2 times 1/2, which is 1. So it doesn't matter how many times you're doing the experiment. If you're working with head or tail, if success rate is always 1/2. So this is binomial, this is discrete, and now the last one is normal. So for normal, they will tell you that the experiment you are doing, it follows a normal distribution. So when you see we follow a normal distribution and we selected our sample randomly, that means you can use the formula. Probability of x equals anything is probability z is less than x minus mu over sigma. And then it doesn't matter which one they ask you use the same formula. You have a problem for greater than. When they're asking for greater than, we don't know how to find greater than from the table. So what we do 1 minus probability z is smaller than x minus mu over sigma. So you find the z from here, go to the z table, get the probability, and then subtract that from 1. For less than, it's simply z is less than x minus mu over sigma. For between, you do the same thing twice and then subtract the smaller one from the bigger one. For the last one, they already gave us the z. So if z, you can use equal sign here, no problem. If you have z is x minus mu over sigma. By the way, all these numbers, these, they all are x, okay? Because they already told us the mean here and standard deviation here. So mean and standard deviation are based on population, and whatever number they give you, that's the x. So they told us our mean is this. They want us to find out the x. So you substitute in mu, substitute in sigma, and use algebra to solve for x. And we did that in class. For the left page, smaller than is easy. We go to the z table and see why do we have negative 0.48. So whatever number we have, we put it here. And for the area, z equals 0 here, so negative 1 here, negative 0.48 is somewhere here. So all you have to do is shade this part, the part which is smaller than 0.48, negative 0.48. Negative 0.48. The next one says this bigger than. Well, we don't know how to find bigger than. So we do 1 minus probability of this less than negative 1.45. You go to the table from the on the negative side, get the probability, subtract that from 1, whatever you get, that's your answer. For shading part, it is bigger than negative 1.45. So z0 here, negative 1 here, negative 2 here. Negative 1.45 is somewhere between negative 1 and negative 2. So you shade this part. This is the area you're looking for. That's the probability. So here, this is, and here, that side. And for the last one, you do it twice. You find a z value for this and z value for that, and you subtract the smaller one from the bigger one. Whatever you get, that's the answer. So you do probability z smaller than 2.11 minus probability z smaller than negative 1.03. Whatever you have, that's the answer. For shading, we have 0 here, negative 1, negative 2, 1, 2. So it says from negative 1.3, 1.03, somewhere here, and 2.11. So 2.11 somewhere here. So the area you're looking for is here. Okay. So 1, 2, 3 points for finding your z-score, and 1, 2, 3, another 3 points for your correct shading area. If you shade the area wrong, you get 0. It's only 1 point, so no partial credit. And these shouldn't take you long. It just go to the table, find the number, put it there. So to complete the entire question, it shouldn't even take you 1 minute. Okay. So these are the 3 types of question you will see in the exam from chapter 7. Uniform, binomial, and discrete. Now chapter 6, huge. So I'm still not sure which question to put in the exam, but definitely something like either I'm going to ask you one question, two events. I'll give you two events and ask you whether they are mutually exclusive or not, or whether they are independent or not. So something like here. Okay. And then there are several parts. What's the probability of this? What's the probability of that? What's the probability of both? What's the probability of neither? And then conditional probability. So something like this table. So definitely number 8, and the rest there will be 3 more, but I'm not sure which 3 more. Disjoint, not disjoint. One example of not disjoint is this. Disjoint means they are separated, they have nothing in common. So here we have two events. One is getting a number that is bigger than 3 and add numbers when you roll a die once. So let's say this is a number bigger than 3 and this is add numbers. So for bigger than 3, we have 3, 4, 5, 6 when you roll a die. And for odd number, we have 3, 5, 1, 3, 5. So you see, they both have something common. They have 5 in common. So we erase 5 from both. So we have 3, 4, 5, 6 here, and 1, 3, 5 here. So they both have 5 in common. We can see clearly. So obviously these are not disjoint. And since they're not disjoint, so their OR formula is different than the disjoint. For not disjoint, the OR formula is probability of A or B is probability of A plus probability of B minus whatever they have in common, probability of A and B. So we can already see we have 4 of them here. So we have 4 out of 6 for A. This is event A, this is event B. Now for event B, we have 3 of them. 1, 3, 5, so it's 3 out of 6. And now this thing is A and B. It means they both have something in common. So we have to subtract that common part. And since only one number here, so it's 1 out of 6. So then we have, bigger than 3, my bad. So it's 3 out of 6. It is greater than 3, not greater than or equal to 3. So greater than 3 means 4, 5, 6. So you have 3 out of 6 numbers. Probability of odd numbers is 1, 3, 5. So you have 3 out of 6 numbers. They both have 5 in common. So it's 1 out of 6. So it's total 5 out of 6. Any question? No. Okay, the next question is something to do with NPR or NCR. So if you're confused about when to use which one, remember the order does matter for NPR. When the order doesn't matter, order doesn't matter, then use NCR. So think about the scenario realistically. We have 35 seats. So when the first person get on, they have 35 choices. And once he sits down, there is one seat left. So the next person comes in. When the next person comes in, they don't have 35 seats anymore. They have 34 seats left. So the second seat is also taken. So you see, the order does matter. That way you are coming, each time you are coming, you are reducing one seat. So our order does matter. So this scenario represents NPR. So we have total 35 seats and we are choosing 7 of them. Whatever we have, that's the answer. Either you do it this way or you do 35 times, 34 times, 33 times until we get 35 minus 7, 20, 28, I think. So either you do this way or you simply multiply all of these and then you get the answer. So I'm not going to give you this question. Okay, I'm going to give you a scenario where you have to ask yourself, does the order matter or the order doesn't matter? If the order does matter, it's NPR. And if the order doesn't matter, it's NCR. Okay. Any question? No. For the rest of the probability, just do them by yourself. I went over every question in class. Oh, except for the last one. Why do the order matter for one again? Because once you are sitting down, you took up your seat. That seat is not available for the next person. Okay, the last one. The last one, actually very easy. They gave us all the information. They gave us probability of E. Oh, let me take a new page. So probability of E is 0.8. Probability of F is 0.6. Probability of E and F is 0.5. And they want us to find out two things. What's the probability that E is happening given that F already has happened? So it's conditional probability. That means the formula. Probability of EF divided by probability of F. They gave us all the information. All you have to do is divide one by another one. So probability of EF is 0.5. Probability of F is 0.6. So it's 5 out of 6. The next one is the same thing. Probability of F given that E has already happened. So probability of E and F divided by probability of what already happened. So 0.5 over 0.8. So it's simply 5 over 8. Draw. Maybe I should do this question. This is very simple. Yeah, I'm still thinking. But yeah, this is a good one. I'd love to do this one. And if they don't give you this one, instead, if they say probability of UF is given, let's say 0.5. They did not give you and, well, no problem. All you have to do is figure that out. We know probability of E union F is probability of A, probability of E plus probability of F minus probability of E and F. We need this one here. So if they did not give us this one, we can solve it. We subtract. It's basic algebra. Okay. So if we add E and F on both sides and subtract this, E union F from both sides. Then we rearrange our equation and it becomes probability of E and F is probability of E plus probability of F minus probability of E union F. So it doesn't matter whether they give us and or they give us union, we still can use one to figure out the other one. So maybe in the homework you have something like this, where they did not give you the and, but they give you only the union. So all you have to do is switch their position, and then you can find what's the and portion. Clear? Question? So that's all for chapter 6. Then the last question, everything together from chapter 1. So question 1, make an order stem and leaf plot. Because in order to do everything else, you need to have an order, you need to order your data set. So it's easy since you have 2 digits. Our first digit is 1 and 2 and 3. So we have 1, 2, 3. These are our stems. And now we are gonna write our leaf. The first one is 11, so it's 1, 1. Next one is 21, so it's 2, 1. Next one is 19, so 1, 9. Next one is 26, so it's 2, 6. Then you have 18, so 8 here. Then we have 11. Then you have 21, so it's 2 and 1. Then you have 14, so 1 and 4. Then we have 17, so 1 and 7. And then the last one is 30. So this is a stem and leaf plot, but it's not in order. So we have to arrange them in order. So we switch the position here, 1 and 6. Huh? And then we have 1, 4, 7, 8, 9. So 1, 4, 7, 8, 9. So you order them. So this is an ordered stem and leaf. So if you don't order them, you'll lose your points. Make sure you order them. Why do we care? Well, when you have an ordered pair, you can easily rewrite them. It's 11, 11, 14, 17, 18, 19. Then we have 21 twice, 26 once, and 30. See, we order them easily. So if you have an ordered stem and leaf, you can easily order them with commas. And then it says find mean, median, mode, range. So mean we know. Let me do mean here. For the mean, you add all the number up to 30 and divide by 10 because you have 10 of them. Whatever you have, that's your mean. For median, you cancel 1 from each side. And you left with 2 numbers in the middle. When you have 2 numbers in the middle, our median is half of the sum of the 2 numbers, which is 18.5. So mean, median for mode is the number you see the most. So we see 11 twice, we see 21 twice, and nothing else. So our mode is 11 and 21. Then mean, median, mode, range. Range is the smallest minus, biggest minus smallest. So you have 30 minus 11, whatever we have. That's the answer. So mean, median, mode, range, order, stem, and leaf. Now 5-number summary. 5-number summary. 5-number summary It contains minimum, maximum, median, lower quartile, and upper quartile. So remember, you must know them for the exam. Minimum, maximum, median, lower quartile, upper quartile. So we can already see that our minimum is 11, our maximum is 30. So minimum, maximum 30, median we already found before. Now for lower quartile, when your middle number has two of them, you take the smaller one and include in the lower part to take the lower quartile. So you cancel one from the left, one from the right, one from the left, one from the right. And whatever remains, that is your lower quartile. Again, the other half from the middle, you include that in the upper quartile. And it is the same process. Cancel one from the left, one from the right, one from the left, one from the right. Whatever remains, that is your upper quartile. See? No math is needed. We're not doing any math. We're just canceling everything. Whatever remains, that's the answer we get. So that's the 5-number summary. IQR is upper quartile minus lower quartile. So upper quartile is 21, lower quartile is 14. So our inner quartile range is 7. And the last thing is scaled, box, and whisker. Scaled means I want you to distribute to number evenly. Our smallest number is 11, largest number is 30. So let's say starting from 10. This is 10, 11, and this is 30. Middle we have 20. Then maybe we can break them down by 3 or 4. So 10, let's say by 2. Can I do by 2? Yeah, let me try by 2. 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 22, 24, 26, 28. So I want each length or each width to have the same width, okay? In that way, you can have an ordered box. So we plot a point on the minimum and on the maximum. And then we make our box in the middle. Our middle is 18.5. So somewhere here. And then we have lower quartile 14, upper quartile 21. So here. So you make the box here. It's 14, 18.5, 21. This is 11. This is 30. And then you make your whisker. So you can see we have a shape, something like this. Okay. We have a big tail and then up and then this. So it's go to the left. Okay, that's all about exam. Any question on anything we went over today or in general? What about the other 2 chapter 8 question on the review sheet? Well, they have the same concept. So those two questions will be good practice about what we learned today from today's material. So it doesn't matter what question you have in chapter 8, they all follow the same concept. You have only two scenarios. Either you are working with proportion or you're working with X bar. So if you're working with proportion, that means you're going to use the first set of information. If you're working with the proportion, you're going to work with the second set of information. Yeah. Any other question? Bernoulli trial is inside binomial. So to find the probability for binomial, we use Bernoulli trial. So yeah, if I ask you what's the probability of getting exactly 3 head or at least 1 tail, those type of question, then you're going to use Bernoulli trial to find the probability. So this is the formula you need to find the probability. Oh, you mean, so here for at least we don't need Bernoulli because we are so smart, we use complement. But if you don't know the complement, then you definitely use Bernoulli to find out the probability. So we're supposed to use Bernoulli to find this probability, but we did not because we have other way of finding it. So if you don't know your complement, then you use Bernoulli. Otherwise, complement is fine for at least 1 tail. But for this question, you cannot use this method. So you're going to use Bernoulli. Any other question from anyone? No. So don't be late, guys. Try to come early, and I will also try to go early, like around 10-15 minutes before class. I'll try that. If you also try, if you go early, I'll give you the exam early. And then you can finish early. So if you need more time, you can finish, you can have your extra that time, the early time, if you arrive early. So you're allowed to use one-sided cheat sheet and any type of calculator. But I prefer scientific. But if you have graphing, it's fine. And I'm going to give you all the thing you need, the Z table. So you don't have to print out the Z table. For our formula sheet, can you print one? Yes, you can print a formula sheet, but please don't print my review sheet with all the questions there and then you solve them. I don't want to see that. And I will check everyone's review sheet during exam. And yeah, if I see that you printed out my exact question from the review sheet and solve them, then I'm gonna take this away from you. Yes, you can do that.
Just to clarify, it's going to be one page, right?
One side.
One
One
side,
page
okay.
doesn't mean 2 sides. It's one side.
Okay, thank you.
Meanwhile, if you have any question, you can email me anytime. I'll reply you at my convenience. So we can't write an example on our cheat sheet, on the review sheet. I don't want you to printed out my review sheet and solved the question there and used that during exam. Okay, so that's annoying. But if you have a few, I don't mind. Can you have a cheat sheet and review sheet with questions? Cheat sheet, one-sided cheat sheet. Definitely use my review sheet to study, but don't use it as a cheat sheet. You have to get your own cheat sheet with all the information you need. Yes, whatever sign is fine. Choose continuity corrections. What do you mean by continuity correction? Will we need to use continuity corrections? What is that? No, Andy. You don't need that method. Whatever I taught you in class, you're fine with that. Or whatever I went over today. All you have to do is remember how to solve anything. Instead of memorizing things, if you know your solving process, if you understand the process, you'll be fine. Okay. Living as a decimal. Yeah, I actually wrote down the direction. If you round to that places. If you leave as a fraction, you just leave as a fraction. You'll see the direction in the exam. Make sure you know the formula for disjoint events, not disjoint event, and formula for multiplication rule for independent events and not independent events. They have the same formula, but the denominator becomes smaller for without replacement. So you should remember the difference between them. Make sure you know what are the things we have in measure of central tendency, measure of variability, what is sample, what is population, what is experiment, what is observational study or experimental study, what are the different types of visualization we have to represent the data set, all those things. Yeah, I'm going to post a lecture video within half an hour. It takes half an hour for Zoom to create the lecture, to create the video. Okay, so good luck, everyone. Make sure you do the homework for practice and your understanding of the materials. Homework has harder questions. Forget about those for the exam. You can do the harder ones after exam, but definitely do easy ones before exam. Okay. You guys also have a good night. Have a good weekend. Study smart. Good night.